Hi, my name is Madison, and today we will be making chromatography butterflies. Before beginning this experiment, let's briefly discuss some background information we need to have in order to understand chromatography. As some of you may know, everything around us is made of matter. Matter is anything that has weight or takes up space. So the device you're watching this video on is made of matter, as well as your floor, your bed, and any other object you can see around you. That matter is made up of atoms. Atoms are extremely small, and you can't see them, but they are all around us. Atoms are made up of even smarter particles, including protons, neutrons, and electrons. However, an atom is the smallest unit that has the chemical properties of an element. An element is a substance that cannot be further broken down by any chemical reaction. And when you have a substance that contains atoms of two or more different elements that are chemically bonded together, that is what we call a compound. Water, for example, is a compound because it is made up of two hydrogen atoms and one oxygen atom per molecule. Now that we know what compounds are, let's discuss the science behind chromatography. Have you ever looked at sunlight through a prism or drops of water? If you answered no, think about if you've ever seen a rainbow. A rainbow is simply the separation of sunlight into different colors of light. Similarly, chemical mixtures can be broken down into different components. Today, we will use a technique known as paper chromatography to view this separation. Before we begin, I want you to think to yourself what you will see if we use paper chromatography on black ink. Do you think the black will separate into a lighter shade of black? Will it stay black, or will it be separated into many different colors? If you want to take a second to think about your answer, you can pause the video here. Okay, so now we will begin the process of making chromatography butterflies. To do this experiment, you will need markers, white coffee filters, a pencil, a pipette, black pipe cleaners, water, and a newspaper or something else to protect your table surface. You can also use a string instead of a pipe cleaner, as well as any other thing besides a newspaper to cover your table, and you can use a spray bottle if you do not have a pipette. Now, let's first choose one marker to begin this experiment with. I would suggest using black or brown, but you can use whatever marker you have available. Then we want to take one coffee filter and draw a thick circle around the center of the coffee filter where the rigid part meets the flat center. Then use a pencil to write the color of the marker being used right in the center. This way you can remember what the original color was that was used, and the pencil won't smear during the experiment. Next, we are going to fill the pipette with water. To do this, place the pipette into water while squeezing the bulb at the top. When the end of the pipette is submerged in water, release your grip on the bulb to let it fill with water. Place several drops of water into the center of the coffee filter, or enough to make the paper really wet. Now we can let the paper sit while the water flows outward from the center of the paper. After the water has reached the outward edge of the coffee filter, place it on a newspaper to dry. Finally, once the coffee filters are dry, scrunch them up in the middle and wrap a black pipe cleaner around the center with the ends styled to look like antennae. You have now made a chromatography butterfly. If you want, you can continue making chromatography butterflies while I further explain the applications of chromatography and the science behind it. Let's consider why a scientist would want to split or separate a mixture. Because they are interested in how things are made and what they are made up of so that they can learn more about the world around us. Can you think of any other reason why a scientist would want to separate particles by weight? Yes, chromatography is a very effective means of separating unknown mixtures in order to determine what exactly is in them. For example, scientists use chromatography to help solve crimes by identifying samples from a crime scene. Chromatography can also be used to monitor pollution by identifying small amounts of unknown pollutants. Additionally, this method can be used to study mixtures like food, perfume, or pharmaceuticals. Just like scientists, we have to separate the molecules by passing them through a solution, water, and then pushing them through some type of medium, in our case, a coffee filter. The molecules of each color that make up black have different masses. You can think of this like weight. The molecules with a lower mass, or less weight, can move farther through the coffee filter than the ones with a higher mass, which are heavier or have more weight. You can think of this like your backpack that you go to school with. You can walk a lot farther with a light backpack than you can with a heavy backpack. While I love using paper chromatography to make beautiful works of art, such as these chromatography butterflies, I'm even more interested in the real-world applications of chromatography, particularly within environmental science. Many of us are privileged to have safe drinking water. However, this is not the case everywhere. In 2017, there were more than 884 million people in the world without access to safe drinking water. That is 1 in 8 of the world's population. And every day, nearly 6,000 people, mostly children, die from water-related illnesses. The severity of poor water quality control is clear, and we need young scientists like you to help us overcome this detrimental challenge. By watching this video, you've already taken your first step to becoming a scientist. Chromatography is a major part of environmental science, since liquid chromatography is becoming a popular separation method in environmental analysis. For example, high-performance liquid chromatography has been used to determine pesticides in river water in either a dissolved or suspended phase. It is also critical that we test wastewater for contaminants at treatment plants before they are distributed back into open water, including our oceans and rivers. I am personally very invested in this research, as I have been participating in the science fair for the past 4 years in the category of environmental science. Last year, I studied a new method of microplastic removal from water, and I hope to continue that study in following years. Hopefully this video not only taught you how to make a beautiful butterfly, but also inspired you to pursue a career in STEM. Thank you so much for watching, and we'll see you in the next video.